This is an absolute max min problem, so the first thing I'm going to do is I'm going to draw my t-bar chart, and it goes from -2 to 4. Don't care about anything outside of -2 and 4. So I need to first find my critical numbers. And that's where f prime comes into play. So bring the denominator up times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared, which is -16x over x squared plus 4 squared. So there's your derivative. Set that equal to 0. Well, that's when -16x equals 0, or x is 0. That's in my interval. And then you would say, well, where does f prime not exist? Well, that's where the denominator is 0. Well, that can't happen. That's always positive, so that's never 0. So now I just do calculations. F of -2 is 8 over -2 squared plus 4, which is 8 over 8, or 1. F of 0 is 8 over 0 squared plus 4, 8 over 4, which is 2. Now I run out of space. F of 4 is 8 over 4 squared plus 4, which is 8 over 16 plus 4 is 20. Common factor 4, and that's 2/5. Now, the biggest this guy gets is 2. The smallest this guy gets is 2/5. So absolute maxes and mins are y values, unless in the application problem it asks you for something different. It says it is estimated that the cost of constructing an office building that is n floors high is, well, there's your cost in thousands of dollars. And what is the marginal cost? Well, marginal means derivative. So C prime of n is 6n minus 300. How many floors should a building have to minimize the cost per floor? Now, this is a minimum. Remember, at this point, we're looking at a parabola that opens upward because it's the degree 2. So it does have a min. Min's at the vertex. How many floors should a building have to minimize the cost? So that says that I need to take C prime of n, set it equal to 0, or 6n minus 300 equals 0. 6n equals 300, or n is 50. So 50 floors.